Okay, this is an example of how to calculate opportunity cost when you are presented with linear equations. So for our specific example, we're going to be hanging out with Molly and Pete, and they are trying to do graphic design on their computers, and they are making avatars and tattoos. Now, the following table that we see show both Molly and Pete, and it shows how many avatars and how many tattoos each of them can make if they were to split their time. So if Molly only made tattoos, she could make 16 tattoos. If Molly only made avatars, she could make 8 avatars. And then we see any combination in between. So if she made 2 avatars, she would have enough time to make 12 tattoos. Pete, on the other hand, if he only made tattoos, he could make 12, and if he could only make avatars, he could do 8 as well. And then again, we see a trade-off. So if he only produced 2 avatars, he'd still have time to make 9 tattoos. We can ignore the colors for a little while. They're gonna be referenced later on. But let's look at our first problem that we're presented with. So given the production possibility tables for Molly and Pete, we can conclude that the opportunity cost of producing avatars is higher for Molly, higher for Pete, or the same for both Molly and Pete. So in this situation, we need to calculate the opportunity cost for both Molly and Pete for producing avatars. So the yellow and blue, so you see I have just taken picked two random relationships between avatars and tattoos for both Molly and Pete. The yellow is for Molly, the blue is for Pete. I picked 4. When Molly produces 4 avatars, she can produce 8 tattoos, and when Pete can produce 4 avatars, he can only produce 6 tattoos. So I've put those in a new table down here, and to find out how much opportunity cost of producing 1 avatar Molly has, I want to get 4 into 1. So avatars, I want to find the opportunity cost of only producing 1 avatar. But here we see that she's producing 4. So to find out how many, if I want to get her number of avatars down to 4, I just divide 4 by 4 to get 1. So this is obtained by just saying 4 divided by 4 is equal to our 1. And then sort of when we look at 2 different sides of an equation, if you do one thing to one side, you have to do the same thing to the other side. It's the same situation here. So if we've divided her number of avatars by 4, we need to divide her number of tattoos by 4. So we get 8 divided by 4, and that's equal to 2. So her opportunity cost of producing 1 avatar is 2 tattoos. If she were to only produce 1 avatar, she's going to give up creating 2 tattoos. Conversely, if we were finding the opportunity cost of 1 tattoo, she can produce 8 tattoos. We need to know what her opportunity cost of 1 tattoo is. So we say 8 divided by 8 to get to our 1. And if we divide one side by 8, we need to divide the other side by 8. So we say 4 divided by 8. And that is equal to 1/2. So the opportunity cost for Molly of producing 1 tattoo is 1/2 of an avatar. So if Molly produces 1 tattoo, she's giving up being able to produce 1/2 of an avatar. Now if we go over to Pete, we're going to do a similar calculation. So he can also produce 4 avatars. So again, we want to look at just 1 avatar. So we're going to say 4 divided by 4 equals 1. And this time we have to divide 6 by 4 because he can only produce 6 tattoos. So we're going to, when we divide both sides by 4, we end up with 1, and then we end up with 3 halves. So if Pete were to produce only 1 avatar, he's giving up being able to produce 3 halves of a tattoo. If we look at his tattoos, we say, okay, well, if he's only, what's his opportunity cost of 1 tattoo? We need to divide his 6 by 6 so that we can get it down to 1 tattoo instead of 6 tattoos. And then we do the same thing to his avatar. So we say 4 divided by 6 is equal to 2/3. So for Pete, if he were to only produce one tattoo, he's going to be giving up the ability to produce 2/3 of an avatar. And so we go back to the original question, and they're asking who has the higher opportunity cost for producing avatars. So if we look at the two columns that are both tiled opportunity cost of one avatar, we see that the opportunity cost for Molly of producing one avatar is 2, and the opportunity cost of producing one avatar for Pete is 3/2, and 2 is greater than 3/2. So we're going to say that Molly has the higher opportunity cost of producing avatars, and that's in reference to higher than Pete's opportunity cost. And we've gone ahead and found the opportunity cost for both producing avatars and for producing tattoos, and that'll be useful in later on, so we'll keep that up there. Our next section says, given the production possibility tables for both Molly and Pete presented above, who has the comparative advantage in each good? Now here we can do this in two different ways. The first way is to use that table above. So use table above. So I told you we had just done more calculations than we really needed. So we're going to go up here and look. Find who has the opportunity or who has the comparative advantage in each good. Now, as a reminder, the comparative advantage, if you have the comparative advantage in producing a good, that means you have the lowest opportunity cost in producing that good. So if we go back to our two columns, each for Molly and Pete, we're going to say who has the lower opportunity cost for producing avatars. Well, if we look, Molly's opportunity cost was 2, and Pete's opportunity cost of producing avatars is 3/2. So Pete has the lower opportunity cost for producing avatars. So Pete has the lower opportunity cost for producing avatars. So he has the comparative advantage in producing avatars. And then we're going to say, then we're going to look, it asks us for the comparative advantage for both goods. So we've only looked at one good. So now let's look at the cost, the opportunity cost of tattoos. So Molly's opportunity cost of producing one tattoo is 1/2 of an avatar, and Pete's opportunity cost of one tattoo is 2/3 of an avatar. So 1/2 is lower than 2/3. So Molly has the lower opportunity cost for producing tattoos, so she has the comparative advantage in producing tattoos. Instead, if we wanted to look at the graph, so that's one method, is to use this table, to use the calculations that we've created. But we've also been given all the points. So if we plot all of our points for both Molly and for Pete, we can compare the overall lines of the graph. Alright, so here are our points, our original points that we saw on the table. So let's go ahead and plot these. So let's start with Molly. Molly can produce, when she's producing 0 avatars, can produce 16 tattoos. So we have avatars are on our y-axis, our vertical axis, and tattoos are, I've lost the, here it is. Tattoos are on our x-axis. So let's move this over. We have, at 0 avatars, we have 16 tattoos. So it's going to be right about there. And then what else does she do? At 2 avatars, she can do 12 tattoos. So at 2 avatars, she can do 12 tattoos. Right there. 4 and 8. 4 avatars and 8. Right there. 6 and 4. There. And last, 8 and 0. So 8 avatars. If she produces 8 avatars, she can't produce any tattoos. So we're gonna go ahead and connect the dots. And so this is Molly's PPF. Similarly, we're going to plot Pete's points. So Pete has, if he only produces tattoos, he can produce 12 tattoos. Right there. If he produces 2 avatars, he can produce 9 tattoos. So 2 and 9 is about here. Maybe up a little bit more. Then what's our next point? 4 and 6. 4 and 6 is about here. 6 and 3. 6 avatars. 3 is about here. And then 8 and 0. So if he only produces avatars, he's in the same spot as Molly. So let's connect these dots to get Pete's PPF. And we'll label it, this is Pete's PPF. So what we see here is that Molly's PPF seems to be flatter toward the tattoos, towards this x-axis, and Pete's PPF seems to be flatter towards the y-axis, towards the avatars. So that's a unique trick that you can do. If it's whichever axis your PPF is flatter towards, that's what you have the comparative advantage in. So Molly has the comparative advantage in tattoos, and Pete has the comparative advantage in avatars. So that's method 2, is looking at our graph. Next portion, what is the linear equation that represents Molly's PPF? Let A equal avatars and T equal tattoos. So only Molly's PPF, they want us to find the equation of that line we just drew. So to find the equation of the line, we're going to use the form y equals mx plus b. Y equals mx plus b is one way you can write a linear equation. There's others, but that's a very simple way, and that's the way we're going to choose today. The m stands for the slope, and the b stands for the y-intercept. And again, they've told us that we're going to call avatars A and tattoos T. And the way we have drawn our graph up here, we have drawn avatars on the y-axis, so A is going to be equal to y, and we've drawn tattoos on our horizontal axis, so T is going to be equal to x. So come down here and we say A equals y and T equals x. Now to find our slope, we're going to use the equation, though, for m, we're going to use rise over run, and that just means the distance between the two vertical points over the distance between the two the distance between the two horizontal coordinates of the points. So you have x1, y1, and x2, y2. It doesn't matter which points you choose if it's a linear equation, which means it's a flat line, it's not a curved line. We're going to come up with the same slope at every point. So I have just randomly chosen those 2 points up there for Molly in the pink. So 0 avatars, 16 tattoos, and 2 avatars and 12 tattoos. So if you come down here, you see in the pink 16, 0 for x1, y1, and 12, 2 for x2, y2. Now I'm just going to plug in and for our y2, y1, x2, x1. So y2 in this case is equal to 2. y2 minus y1, and y1 here is 0. And then we're going to say x2, which is 12, minus x1, which is 16. So we end up with 2 minus 0 is just 2. We divide that by 12 minus 16 is negative 4. And 2 divided by negative 4 is negative 1/2. So the slope of Molly's PPF, the m, is negative 1/2. To find our y-intercept now, what we're going to do, there's two different ways we can do it. We could just go up and look at our table, our original table, and you see that they've already given it to us. So where we said our y-intercept occurs where x equals 0, and here we said x is tattoos, our horizontal axis. So when tattoos equal 0, which Molly can produce 8 avatars. So technically we already know what our y-intercept is. It's given to us in the table. But assuming later on down the road we come across an example where they give us a bunch of points for Molly's PPF, but they don't give us the point that includes the y-intercept, then we need to show the long way of how to calculate it, so that's what we're going to do here. So to calculate our b, which we already know is 8, but that'll be a nice check to make sure we do it right, we're going to plug in the slope that we just calculated. So we're going to plug in for m our negative 1/2 that we just found, and we're going to pick a point to plug in for y and x. So y and x here represent all the y's and all the x's, but to find our specific b, we're going to use a specific point, and I've just chosen to do the first point. So x1, y1 makes it easy. The number's already right there for us. So our y in that point is our 0, and we're going to put back in negative 1/2 for our slope. And now we're going to plug in our x, which is x1 in this situation, which is 16. And then we're going to say plus b, which is what we're going to solve for. So 0 equals negative 1/2 times 16 is negative 8 plus our b. And we're going to add 8 to both sides to get rid of that negative 8. So we're going to say 0 plus 8 is equal to negative 8 plus b plus 8. So then negative 8 plus 8 cancel each other out, so you have b on the right hand side, and 0 plus 8 is just 8, so you get that b is equal to 8. Now this doesn't actually give us our linear equation, this just gives us our slope and our y-intercept. We actually have to plug it back in to our y equals mx plus b form to get our linear equation. So y equals our m, which we calculated to be negative 1/2. So we plug that in, put our x back, and then say plus our b, but our b is 8. So we put that in, and so our linear equation ends up being y equals negative 1/2 x plus 8. And then our final portion asks us, if Pete and Molly were to specialize in trade, then after trading's complete, is anyone better off and is anyone worse off? So I've again just randomly chosen 2 points for Molly and Pete. So let's assume that Molly and Pete, using their separate PPFs before they specialize in trade, I just picked the point, what was 4, 6, and 4, 8, so it's 4 avatars. So at 4 avatars, Pete is operating here and Molly's operating here. I could have picked any of the other points, it doesn't matter, but I just randomly chose these points to do our comparison. So 4 and 8, 4 and 6, these are the same points that I chose before. Before they specialize in trade, our market has a total number of avatars, which would include the number that Molly can make and the number that Pete can make. So we get 4 plus 4 equals 8. And then similarly, our market before they specialize in trade, so Molly's making some avatars and some tattoos, Pete's making some avatars and some tattoos. And in our market total, we're going to have 8 plus 6 equals we're going to have 14 tattoos. Now let's suppose that they decide to specialize in trade. We can assume that they're going to specialize in whatever they have the comparative advantage. We've already decided that Pete has the comparative advantage in avatars and Molly has the comparative advantage in tattoos. We already figured that out earlier. So if Molly has the comparative advantage in tattoos, that means she's not going to make any avatars. She's only going to make tattoos. If she only makes tattoos, then that means she's going to be operating on that horizontal axis and she's going to be making 16 tattoos. So we're going to plug in 16. Now Pete has the comparative advantage in making avatars, so he's going to make 0 tattoos when he specializes, but now he's able to make 8 avatars. So he's on the vertical axis. He's that far point on the vertical axis. So he's making 8 avatars. Now, after they've specialized and traded, how many avatars are in the full market? Well, that includes both Molly and Pete. So now we have 0 plus 8 equals 8 total avatars. And then in the market, that includes Molly and Pete, we now have 16 plus 0 equals 16 tattoos. So overall, in our market, before they specialized in trade, they had 8 avatars. After they specialized in trade, they still had 8 avatars. So nobody is worse off, but nobody's better off either in that situation. But that's not the only goods in this wherever Pete and Molly live. So maybe in their own country, I don't know. So then we say, okay, well, if they're not any better off or any worse off with avatars, what about tattoos? So before they traded, they had 14 tattoos in the market. After they traded, they have 16 tattoos in the market. So they're actually better off after they trade in the market for tattoos. So we would say that Molly is better off and Pete is better off. So hopefully from here on out you should be able to use linear equations to help guide you through calculating opportunity cost.